Good day, folks. Welcome to my YouTube channel. If you're new here, please don't watch my videos without subscribing. And subscribing, it costs nothing. And immediately you press the play button of my video, please press like, and you can share with your friends and families. And yeah, watch my video till the end. Don't skip the ads. Thank you so much for the support. Keep on doing that. Today we're going to look at the universal gravitational law, which is the grade 11 and grade 12 topic. And yeah, let's cut the chase. Now, in this question, it says the statement a Luhlaza High School teacher has a mass of 78, that's not me, is standing on the surface of the earth, and the diagram is not drawn into scale. Here's a teacher, and the mass of the teacher is 78 kilograms. I weigh more than that, and I'm not proud of that. And then there's a mass. One thing that you need to understand as the person is standing um, on the surface of the earth, the distance between him and the center of the earth, which is the radius of the earth, the radius of the earth is a constant, which is at 6,38 times 10 to the power 6 meters. So that's the radius from center to circumference, the distance between them, right? And then there's a mass of the earth. Mass of the earth, it's 5.98 times 10 to the power 24 kilograms. And then now there's a force between them, the force that the earth exerts on the person and the force that the person exerts on earth. We call that, it's a gravitational force, right? Which is the weight. Now 5.1, it says state the Newton's law of universal gravitational in words. Guys, I'm not going to waste time on that. Please check your exam guideline and memorize that definition. It's very straightforward. And go to my previous video, I explained the definition there. 5.2, it says calculate the magnitude of the force of the earth exert on the teacher. In other words, we want the gravitational force, which is the weight. So the way we're going to do it, it's F is equal to, you write the formula, G times mass 1 times mass 2 divide by R squared. And then the mass 1 is going to be the mass of the teacher, and then mass 2 is going to be the mass of the object, right? So it's very important, the mass of the earth, sorry. So G is a constant as well. It's 6.67 times 10 to the power negative 11. And then mass 1 is the mass of the teacher, which is 76 kg. And the mass 2 is going to be the mass of the earth, which is the constant. It's 5.98 times 10 to the power 24. You don't have to memorize that. We divide by the radius, which is the distance between them. It's the constant as well. It's 6,38 times 10 to the power 24 square. So if you punch that in the calculator, it's 6. The answer will be, so what is wrong here? The answer will be, it's 744 0.73 newtons, right? So that's the gravitational force that the earth exerts on the person, right? So there is an alternative way that you can calculate that. We can use the weight, which is equal to m times g, which is the mass of the teacher times 9.8. So it's 76 times 9.8, which is going to be 744.8 newtons, which is the same way, but I prefer this way. Right, sorry for that. Now let's answer the following question. The following question, it says use your answer in 7 and 5.2 to calculate the new force if you have the distance between the earth and the teacher. Guys, theoretically, um, the relationship between the force and the distance is what? Is inversely proportional. By halving the distance, which is we decrease the distance, that means we will get the greater force. So it will be a greater force than this. But now let's look at that proportionality. So the new force, so what will be the new force if you are halving the distance? When you halve the distance, you put half r squared there. So it will be 1 over 4r squared. So the new force here, since it's 1 over 4, so that means the distance, it decreases 4 times less. So the distance, it's 4 times lesser. Now the force, now it will be 4 times bigger. The new force, it will be 4 times bigger. So the force is 4 times bigger. So if the distance is decreasing 4 times, the force will be 4 times increasing. So the new force there will be 4 times, and then we take the force that we calculated there. So it's 744 times 7 3. So there it's 744,73 times 4. So it will be, yes indeed, it will see it's 2,978,92 newtons. That's the new force when the distance is halved. Distance is halved, the force is going to be what? Bigger, right? So now it says prove by calculation that the gravitational acceleration of planet Earth is 9.8 meter per second square. Guys, I've covered that in my other videos. So it's 5.3. So we prove by the formula. It says G is equal to G, mass of the Earth, divided by the radius of the Earth square, which is going to be 6.67 times 10 to the power negative 11. So in this one, you prove it by all the constant that you have them in your data sheet. The mass of the Earth is 9.8 times 10 to the power 24, and then we divide by the radius of the Earth, which is 6.38 times 10 to the power 6 square. So if you punch that in your calculator, you have 9.8 meter per second square. That's the gravitational acceleration of planet Earth. I hope that makes sense, guys. Cheers. Bye.